Kyverno's mission is to simplify Kubernetes policy and governance. And I know that sounds like a mouthful, but today what we want to do is go over a little bit about the history of the project, why we started Kyverno, why this matters for Kubernetes, and more importantly, what's the future of policy and governance for Kubernetes, as well as other platform engineering concerns. So just quick introductions. I'm Jim Bugwadia, co-founder, CEO at Nirmata. We're one of the main contributors. We also created Kyverno and are very active in the community.
And I'm Charles-Edouard Brétéché. I joined the Kyverno organization as a Kyverno maintainer 3 years ago. And now I work at Nirmata with the creators of Kyverno. So thanks, Jim.
Awesome. All right, so let's start with why do we need policies to begin with, right? So one of the things which I find very interesting about Kubernetes is if you look at the history of computing, right, the last like even going back 30 or so years, we talked a lot about DevOps and DevSecOps and other things, but Kubernetes is one of the first platforms that really brings together developers, operators, and security teams. You actually have YAML manifests, whether you like YAML or not. You have configurations which are super detailed, very specific in terms of every aspects of concerns for each of these roles. So the question always becomes, how do you now manage policies, or how do you manage across all of these roles, and how do you share information in an efficient manner? Now, obviously, we could share things, like by conversation or by tickets or other means of communication. But what we know best is, configuration. So, of course, like creating policies as configuration or policy as code also starts making a lot of sense. So that's really what Kyverno was intended for. It's, I kind of think of it, policies in general, just as a way of communicating or defining ways that we, agree to a certain set of rules. Now, of course, like as we were mentioning with Kubernetes, you have different roles, you have different concerns, all in the same YAML configurations, and policies really bring together a lot of these roles, right? So why Kyverno? There's options, like Kyverno started maybe a couple of years after other policy engines in the space, like Open Policy Agent and others that you might know. And we thought long and hard before we created Kyverno. We spoke to a lot of folks. And what we found is that although almost everybody understood the use case for policies, there was very little adoption because of the friction involved, right? The language matters. And as Kubernetes admins, a lot of us, we learn Kubernetes constructs. So what we wanted to do was make policies very native to Kubernetes, make it very frictionless and seamless for administrators or developers or even security teams. So one of the main things, even in hallway conversations and talking to folks that I've heard, is although there's other admission controllers, your security tool might have an admission controller, maybe there's other options in the space, Kyverno makes it really, really simple for everybody to understand what's going on, for everybody to do their job, troubleshoot, look at things. So even with, like as we'll see, with reporting, with exceptions, with other workflows, Kyverno is designed for that level of collaboration, which is what makes it very unique. The other point, which you'll see as we look at policy examples, is Kyverno is the only tool that covers the full life cycle of resource management. So policies are not just for security or validation. You want to do policy-based operations and management as well. And tools with just validate and block are not going to be able to do that. So you need to be able to mutate resources, generate resources, clean up resources, and just like Kubernetes controllers do this in a control loop, think of Kyverno as a lightweight controller framework which lets you write declarative policies and rules which are always acting on your behalf. So you don't need to be logging into every cluster. Kyverno is in there doing a lot of the work for you. All right, so just a little bit of the history of the project. So Kyverno started in 2019. Interestingly, much like Kubernetes, the initial version of Kyverno was written in Java. It ran off cluster as a central policy engine. But then as Kubernetes evolved, admission controllers were added, CRDs were added, and it just made sense to bring Kyverno native to Kubernetes. And then since then, we've seen massive adoption, a lot of good feedback from the community, a lot of inputs into what policies should be doing. And we have since moved to an incubating status in CNCF, which is one step away from graduation. And now what we're doing is, as Kubernetes evolves, we've also updated a lot of internals of Kyverno, and we're getting ready to, in the next quarter, we will file for graduation and look at that next evolution of the project. So in Kyverno, with the latest release, there's 5 main policy types, right? And there's also some other policies which some of you might be familiar with, and I'll talk about. So there's validating policies, which of course check for things and various configurations. They can either block or audit your resources based on your settings. There's mutating policies, which you can use to inject secure defaults, inherit labels, automatically, like even set resources, default resources, lots of use cases for that. And by the way, one question I get often is, how does this work with GitOps? Shouldn't I be mutating in my CI/CD pipeline? Kubernetes is designed for something called server-side apply. And this works really well with GitOps controllers if you set them to recognize, and both Flux and Argo CD do this now, is you have to enable server-side apply, and mutating and generating policies work extremely well because different controllers know who's responsible for different portions of the configuration. So, and then there's the generating policy, which can create new resources. There's several use cases for this as well, like when a namespace is creating secure defaults, roles, role bindings, quotas. Also, like things like network policies, you want to automate a lot of these things for your developers and application teams. There's a deleting policy for cleaning up resources. So we all know in our clusters, things tend to pile up, right? People, there's pods which don't start. There's maybe replica sets which pile up. There's other things, config maps which might be left behind. Cleanup policies are your tool for that. They can delete things and keep your clusters optimal. And there's also an image validating policy which integrates with tools like Sixt or Cosign, but Notary for image signing, as well as artifact signing and verification. All right, so let's dive into how does all of this apply into Kubernetes, and we'll take a look at some examples as well, right? So the main form factor for Kubernetes, for Kyverno, is admission controls. And in Kubernetes, it's extensible, so there's a way to register admission controllers. You could write your own, or you can use tools like Kyverno, where anytime there's a change request within a Kubernetes cluster, the Kubernetes admission controller kicks in, and that configuration changes are sent to the admission controller, and it will either allow or deny those changes. So Kyverno acts as an admission controller, pre-caches all the policies. It will run some of these depending on whether you have audit or enforce. Some of these will apply right away. Others will be deferred for background processing. So Kyverno is designed for like high optimization and very low latency operations. So it optimizes based on your policy types and to keep that friction minimized. Kyverno also generates like policy reports, like both at admission controls as well as for background processes that might be running. All right, so the other thing you might want to do is sometimes you don't want to install anything in your cluster. You just want to try out a policy, right? Or you just want to download Kyverno and see if you apply some policies, what would happen. So the Kyverno CLI is designed for that. And what it does is you can use the apply command to apply various policy sets, either from Git repos or from your file system or even from other sources to your clusters. And it's very simple. This one animation kind of quickly shows what that would look like. So here we're going to run the apply policy first from a GitHub resource. So it'll fetch a set of pod policies, other best practice policies, and then it applies them to your cluster. And now it's applying the same ones from a file system, right? So you can even apply to resources in your pipeline in the file system, and you can produce this reports. So Kyverno supports something called OpenReports, which is just like OpenTelemetry, but for reporting. And you can apply these reports or produce these reports both in cluster as well as off cluster and ship them to whatever monitoring or other tool that you might want, right? So just a quick example of how that works Yeah, so what about now, like I mentioned, Kyverno is also evolving, right? So as Kubernetes, of course, is every 3 months or for 3 or 4 months now, we expect a new release. Kubernetes keeps adding lots of awesome new features. And as Kubernetes evolves, projects like Kyverno and others also evolve. Our mission is to remain very native to Kubernetes and complement it in ways where we can make a difference. So one of the things that was added to Kubernetes was this use of CEL, or Common Expression Language, right? So this is used in CRD validation. It's also used for if you're writing your own admission webhooks. You would use CEL expressions for match conditions over there. And Kyverno has now fully adopted CEL as its policy language, and that's what we're designing the new policy types on. So previously, Kyverno was using something called JamesPath, which is another kind of built-in language for evaluating JSON payloads. JamesPath and CEL are very similar in many ways, but CEL has some predictability, cost, and performance aspects, which is why the Kubernetes team chose that. And Kyverno is also now standardizing on that, so you get a seamless transition. More than that, what we wanted to do is previously we had a single cluster policy with different rule types, but now we have separated out each of the policy types into their own CRD. So this also makes it easier to manage. It makes Kyverno more modular. And as Charles-Edouard will talk about the SDK and other things, this matters in how we scale the project and how we can reuse policy elements even outside of Kubernetes for like Terraform and other use cases, right? So just to kind of put that in context, in Kyverno 1.14, we introduced the latest release, which was just, the GA is out this week, is 1.16. So 2 releases ago, we introduced the validating policy. And what the validating policy does, it starts with the Kubernetes validating admission policy, and then it adds about 3 new different element types above that, right? So there are things that Kyverno does which you cannot do with validating admission policies. So we need new constructs in the Kyverno declaration for that. So that's what it does. And then it also adds some more CEL libraries for more complex use cases. So this is how we extend Kubernetes in a very clean manner and allow you to kind of start with validating admission policies if you wish, and then extend them to Kyverno validating policies. So here's an example of how all of this comes together. So pretty straightforward if you're familiar with how CEL looks. There's a little bit of syntax involved there, but not too hard to understand for anyone who kind of knows what a Kubernetes resource is like. So just very quickly, so then you might say, OK, why do I need Kyverno if Kubernetes also has policies? Several reasons, and I'll highlight a couple of important ones here. The main thing is validating admission policies, like the name suggests, only work during admission. Reality doesn't work only during admission, right? You have existing workloads, policies change, other things change, admission controls are down. You need background scanning, you need continuous monitoring of your resources. Kyverno does that. The other thing, you want to test policies, you really want to do policy as code, you need to test policies off cluster. Validating admission policies are not going to help with that. And complex policy types require like lookups, require caching, require other things, which you also cannot do in validating admission policies. So it's useful for a very limited set of use cases. It's a good starting point. But very quickly, what we see is people want to migrate to full Kyverno policies. And that's where there's a lot of other features like reporting, exceptions, and other things you would get. I won't go through all of these use cases, but Kyverno has lots of use cases, not just for security. Security is usually the starting point, but also for operations management, automation, several other things. So if you go to our kyverno.io and click on policies, you'll see several like sample policies for each of these use cases. All right, finally, one thing I want to cover before I hand off to Charles-Edouard is Kyverno for IAC. So remember I said we started with Kubernetes. Our mission is to be the best policy engine for Kubernetes, but now we've also extended Kyverno to work beyond Kubernetes for things like Terraform, for authorization, for several other use cases. So the same validating policy we saw, and this is one of the reasons why we took the step to evolve to this, is now you can cleanly extend that to work for even Terraform payloads with a few lines of changes, right? So you really, it's the same cell expressions that we use, but now you, instead of working on a Kubernetes payload, you're working on JSON as the data type. So that's what's done where it says mode JSON. And then you write a match expression. So in this case, if you want to match an ECS cluster, you would write a match expression to look at your Terraform JSON. So basically, this is assuming you've converted your Terraform plan into a JSON output, which the Terraform CLI allows. And then the next thing you would do is basically apply a policy to it. And you can write cell expressions just like you would with regular Kyverno policies. In the next section, Charles-Edouard will now cover Kyverno for authorization, which is one of the new use cases we do.
Yeah. So all these policies becoming more and more generic. So we could see that it works for Kubernetes, it works for IOC, and now why not bring policy as code to authorization? It started with a Kyverno Envoy plugin and now evolved into a full authorization server. So the basic idea we had was, let's do something like this. So this is for Envoy based on Istio. So we can see that a request comes into the pod, is intercepted by the Istio proxy, then it communicates with the Kyverno ODZ server using the XODZ protocol from Envoy. The Kyverno ODZ server watches Kyverno policies, then it can make a decision to allow, deny, and of course it's based on the Envoy protocol, but it can make the decision. It's a validating policy in the end. We can imagine the same thing for reverse proxy, Nginx, or Traffic. That's a bit different. The protocol is not the same, but the concept is the same. When we first started working on authorization with Kyverno, our goal was really simple. We just wanted to explore how far we could push Kyverno beyond Kubernetes admission control. So could we use it to authorize live traffic? We started very small. We created a dedicated policy type specifically designed for request level authorization. It was based on Kyverno JSON, which was another implementation. And finally, we built everything around Envoy. Envoy was our first target because it had the protocol for that, so it was easy. Then we started to gain confidence, and users started experimenting it. We realized that we could leverage the Kyverno's validating policy, finally, because it's the same layout. It's just manipulating different input, producing different output. And in the end, it became a truly generic and programmable ODZ server that can work with both HTTP and or Envoy and adapt easily to different protocols, so Traffic or Nginx. Leveraging validating policy looks like this. Finally, this is the same policy, but spec.evaluation.mode determines the consumer for this policy. Each consumer compiles the cell expressions according to its needs. Input object might have a specific structure. Output can be a complex object. Cell offers compile time validation to detect incorrect usage. So on the left, we see a policy for Envoy. On the right, we see a policy for HTTP authorization. So only the evaluation mode is different. And finally, both HTTP, Envoy, and other stuff have different needs. So for that, we implemented different cell libs. Of course, we have a lib to work with job tokens, with JSON web case sets, with JSON, with HTTP, with the Envoy protocol. We added Kubernetes libs. We added Kyverno libs too, so you can cache data, you can make HTTP calls or fetch a resource from your cluster. So eventually, your policy can make a decision based on what you have in a config map or in secret. And if we look at the policy, so the first thing we can notice is that it's the same structure, but we know that already. The evaluation mode was Envoy, is Envoy in this case. We have a first call to JWKs. Oops. Don't move.
Yeah.
OK, so. So yeah, we have a call to jwks.fetch, which is fetching a JSON web key set. We have another call to jwt.decode. This call will decode a JWT token based on the certs we previously fetched. And finally, we are all at the bottom, we have envoy.denied.response key, which is responsible for creating the response sent to the envoy proxy. So let's try to do a demo. I have a cluster running locally with Istio deployed and a keycloak. So there's an app. It's HTTP bin, so a very simple app, we all know. There's no policy, no nothing. And I should be able to call into this app and I get a response. So if I try that, OK, everything works. I have a token coming from Keycloak, and the HTTP bin replied with a JSON payload corresponding to my request. Now, I can apply an Istio policy to let Istio send authorization requests to the authorization server, and I can create a policy, so the one we had in the slide. So it fetches the JSON web key set from Keycloak. It decodes the token, and this time it works. Now, if I change and use the JSON web key set from Cognito, for example, the decoding should fail and the request should be denied. So I can just change this policy. Of course, I didn't copy everything. So yeah, let's change this policy. And if I try, this time I have 403. So if I just show the logs in the ODZ server, well, no, I'm not in the right terminal. OK, we see that it failed to parse the key provider, to verify the key provider with this key, because that's not the correct JSON web key set. So that's it. We have a policy based on YAML, so a complete validating policy that is applied to Envoy. We can do the same with HTTP. Of course, Envoy has a dedicated lib. HTTP authorization has a dedicated lib too, and some libs, some cell libs are common to both authorization system. We have more features that we won't cover right now, but you can run it as a sidecar, so it will reduce request latency. You can run it as a central server, but of course, it's more load. No, it reduces the load at cost of latency. We have observability, logs and metrics are present, traces are coming. We have external sources. We can load sources, policies from the file system, from Git, from OCI images. And we are working on addressing MCP, which is the next big application domain we want to apply policies on. Finally, the Kyverno SDK. We created that to allow embedding the Kyverno engine in your own application, enforce policy control point inside your software directly, and eventually extend the engine and reuse SDK components. So we have a couple of components at the core. We have a source, a handler, a middleware, dispatcher, evaluator, resulter, breaker, and all these combined to build an engine. In the end, it looks like this. The engine fetches policies from policy sources. Then it goes through middleware, handler, and ends up in a dispatcher that will run policies either sequentially or concurrently. The evaluator will evaluate the input context with a single policy, and the resulter will bring you a result. All this is built, the core is fixed, but we have a couple of extensions around it. We have extensions for controller runtime, for Kyverno API, for Cell. We plan to integrate reporting with OpenReports. We plan to integrate exceptions and MCP. And yeah, that's it. So I will let Jim conclude.
Yeah, so I know we covered quite a lot of things in a short amount of time, but we'll be around to take questions and talk about other things. But really what we're focused on now is wrapping up the work on the new policy types. We have lots of plans for new features, everything from OCI, better OCI support for policy sets, to even running the Kyverno off-cluster potentially, so lots of things coming up on the roadmap. But the main thing people want to know is, okay, what's the path to complete up the API types? So our plan is like with 1.18 is where we will not only GA the new policy types, but we'll mark the older policies for deprecation. We are looking at migration tools and helps and utilities. But the whole point is the sooner you get started and get familiar with cell policies, which are already part of Kubernetes, this kind of helps you on that path. And of course, there's lots of other items and things we will continue working on. But hopefully you see how Kyverno started with a simple idea, let's make policies easy for Kubernetes admins, but has evolved into a full-fledged framework of tools with reporting, with exception, with full lifecycle resource management, which lets you do a lot of powerful things across several use cases in your clusters, right? So we had lots of, if you didn't catch these sessions yesterday and today, of course, the recordings will be out in a couple of weeks. And there's also a Contrib Fest tomorrow, so where Charles-Edouard, myself, Courtney will be there to help answer any more questions. And feel free to join the community, of course, or stop by our Kyverno kiosk in the project booth. So that's all we had. Thank you very much.
Thank you.